Gangnam Style.
Hello everyone, and welcome back to this Networking Basics mini lecture series. In this mini lecture, we will address, or we will view the three different types of addresses that we find in any IPv4 network. The topics for this mini lecture include the address types in any IPv4 network, how we calculate these three address types, and some simple examples. Within each network segment, we find three types of addresses. We have the network address, also known as the network ID or the area code if you want. We have host addresses and the broadcast address. The network address uniquely identifies the network. Host addresses are the addresses that we use, or that are used and to assign two devices. These devices then can communicate over the network. And then finally we have the broadcast address, which is a special address used to send data to all hosts in the network segment. Let us look at these addresses through a simple example. Here we have a network that consists of two network segments. Here we have segment 1 and segment 2. Each segment has a separate and independent interface on the router. And furthermore, each segment connects computers within the same network ID. Therefore, all computers on this network will all have in common their 24 network bits will all be identical for this network. We conclude that with the slash prefix. Same thing here. The prefix length here indicates that in this network all computers will share the same network ID. They will all have the same network address. And if you recall what we learned last week, a slash 24 indicates that the first three octets represent the network portion of the address. So in this case we have 172.16.2 is the portion that is common. That is our area code if you want. And in this network, the network ID is 172.16.1, and that portion will not change across devices of that segment. The portions that will change is the .x, and over here the .x. Our area code remains unchanged. It is the .x that is the variable portion in every network. And it is like an area code. We do not find a repeating area code around the world, and the same goes with the network ID. The network ID is unique in that network. Alright, so let us look at the three components. So we have the network address, which is 172.16.1.0, where the .0 is the, and then for the same network, the host addresses. The first valid host address is at 172.16.1.1, and the last one is 172.16.1.254. And any address in between is a valid address that we can assign to hosts on that network, to devices, computers, laptops, printers, etc. And then finally, the last address in that network is the broadcast address, and it is 172.16.1.255. Alright, so on the next slide we will look at the formula or the method that enables us to calculate these three components. That is the network address, the host address range, and the broadcast address. In order to calculate the network address, you set all host bits to zeros. In order to calculate the broadcast address, you set all host bits to ones. And the host addresses are range between your network address +1 to your broadcast address -1. And the number of hosts in any network is 2 to the power h minus 2, where h is the number of host bits. And remember, network bits are constant for all addresses of the same network. Alright, now that we know what the formulas are to calculate, let's do an example together. So let's calculate the three components, that is the network, broadcast, and host addresses for 192.168.15.100 with a /24. The /24 means that the first three octets of our address represent the network and are constant throughout the addresses in that segment. So let us calculate the network address. So in the network address, all host bits are zeros. So this is our network portion, and this is our host portion. So if all host bits are zeros, what is the value of an octet with all zeros? Yes, 0. So our network ID is 192.168.15.0. Our broadcast address, all host bits are 1. So here we have, if we set all host bits to 1, 1, 2, 3, 4, 5, 6, 7, 8, and we convert that to decimal, what does it give us? Yes, it gives us 255. So our broadcast address has this address. Finally, what are the host addresses? What are the addresses that we can assign to devices connected to this network? That is computers, laptops, smartphones, printers, servers, routers, etc. So the host addresses, based on our formula, range from the network address +1 to the broadcast address -1. So what is the network address +1? Well, 0 plus 1 is 1. So our first valid host address is 192.168.15.1 to 192.168.15. Oops, sorry. This should be 254 because it is the broadcast -1. Finally, in the network, in network ID 192.168.15.0, how many hosts can exist in this network? So the formula is 2 to the power h minus 2. So 2 to the 8 is 256 minus 2 equals 254 host addresses can exist on this network. You may be asking, well, why 2? Well, in every network we have two special addresses. We have the network address and we have the broadcast address, which happens to be the first and the very last address for that network ID. Therefore, -2. Let's do another example together. So here we want to calculate the three components for 172.16.10.254. So we have this IP address and we want to calculate all three components. As /24, right off the bat we know that the first three octets represent the network ID, and these bits never change. Only this octet will change. So right off the bat, our network address, we know that it will be 172.16.10. If all bits are zeros, what is an octet with all bits at zeros? Well, it's 0. The broadcast address, which is the last address of that range, is 172.16.10. All bits are 1 in our octet, converts to 255. The range, so we know it's 172.16.10.1 to the broadcast, which is 172.16.10.254. And number of hosts in the network is 2 to the 8 minus 2. Again, minus 2, because the first and last address are special addresses. One for the network and the other for the broadcast. So this equals 256 minus 2 is 254. 254 hosts. So we have 254 addresses that can be allocated in this network. Therefore, 254 hosts that can exist at any one time. Another example here, let us look at the address or the components for your home network. So your home network is very likely to have a 192.168.1. something /24. The /24 means that your network ID at home is 192.168.1. Your X is 0 for the network ID. You have your subnet mask, sorry, not your subnet mask, sorry, your broadcast address for your home network is 255. And all of your devices will have an IP address that will be in the range .12.254. So on your home computer, or so your home network, you can have up to 254 addresses. So you have 254 addresses you can allocate. Practically, it doesn't make sense. You likely don't have an ISP connection that would support 254 devices, and as we will see a bit later, 254 computers on the same network could potentially cause some problems. I mean, it would work, but you would experience certain things that we will discuss a bit later. Alright, so we've seen some very simple examples. So in this mini lecture, we covered the 3 types of addresses we find on any network. Network address, all host bits are zeros. Broadcast address, all host bits are ones. Remember, the network bits never change. Never change. Host addresses range between the network and broadcast address. And remember, the network portion is constant across all addresses of the same network segment. Alright, part 2. So once you've mastered and understood what we just talked about, listen to part 2 of this mini lecture, where we will deal with more complex examples, which include subnet masks that are not wholes of that are not octets, but are portions of octets, or for example /25, 26, 27, etc. Alright, so look forward to seeing you in the next lecture.